So today we're very excited to welcome Dr. Michelle Moyer with Washington State University Viticulture and Enology. She is at the WSU Prosser Irrigated Agriculture Research and Extension Center, which is a mouthful. Michelle is professor and the statewide extension specialist for viticulture. And what she'll be talking about today is work that she did with her graduate student Jesse Stevens, looking into the conventional wisdom about not spraying sulfur fungicide in the heat. And let me stop there so that I don't give away any spoilers. Michelle, I'll stop sharing my screen, and if you want to go ahead and take it away.
Perfect. Just got to organize the digital screens here a little bit. So, Julie, can I get a verbal that you can see my screen?
Yes, indeed, we can see it.
Perfect. Thank you. All right. Thank you, Julie, for the invite, and thank you for everyone who's attending. I will say when Julie and I were picking June as a chance to give this talk, we figured, by then we'd have some nice heat. But I don't know the rest of you, for folks that are not in Washington State. Apparently here in Washington, April and June decided to switch each other in terms of temperature. So we're not really experiencing high heat right now, but hopefully this topic is still timely and helpful for the growers in the audience as we move through the rest of the growing season. So as Julie mentioned, we will be talking, or I will be presenting some work that we have done here in Washington State, but I'm also going to use this opportunity to talk a little bit about just the history of sulfur use, the history and thought processes or kind of fears on why we think about phytotoxicity when we think of applying sulfur treatments during heat. And then we'll place some of those, both current research and some of that historical stuff into practical context and understanding with a few key takeaways for vineyard managers at the end of the session. So first, let's start with a little bit of history on why we use sulfur in vineyards and why we are so sometimes polarized by that use in vineyards. And fundamentally, when we start thinking about sulfur use in wine grape production, we really are focused on its use in terms of how we've used it to manage grapevine powdery mildew. And if we add some of the context to that, grapevine powdery mildew and Vitis vinifera really were not two things that were exposed to each other until about the mid 1800s. And that's when powdery mildew, which is a fungus native to North America, was introduced to Europe on various grapevine cuttings, and where it then propagated out and spread across most of European viticulture and pretty much decimated the European industry at that time. And then, of course, treatments with sulfur, either dusting sulfur or sulfur in the form of Bordeaux mix, obviously with copper, was shown to kind of control some of that. And of course, it also was, especially Bordeaux mix, was also a control mechanism for downy mildew, et cetera. So kind of the early advent is we used fungicides pretty sulfur for powdery mildew and downy mildew and Bordeaux mix for downy mildew pretty early on in production systems in vinifera. And of course, that became kind of standard practice, and we've used it since. And that's what this fantastic little chart shows here on the screen. Let's see if I can get my little laser pointer for you. And what you're actually showing is a nice old graphic of grape production, right? So in 1850, then powdery mildew, also known as Oidium, was introduced. Production systems in Europe nearly bottomed out in terms of lack of being able to grow grapes due to powdery mildew. We introduced sulfur. Suddenly, production of wine grapes increased a lot. Then, of course, phylloxera bottomed out, and then we developed resistance vines. So this is just an old article just describing how impactful both powdery mildew was and the introduction of sulfur for disease management. So again, early sulfur use was elemental. Lime sulfur was also pretty common then, also homemade. So that you'll see some historical recipes of add sulfur, add lime, and then boil, which is kind of fun for those that are into some of that historical disease management. And really, the big question is how many other fungicides do we have available to us that really have withstood the test of time? So we've been using sulfur for 170 years. It's just as efficacious as it was prior or in the early stages, if not more so, based on improvements in formulation and application approaches. And it has extremely low fungicide resistance risk. So it's a fantastic fungicide in this regard, but yet we still sometimes are nervous about using it for various reasons, which we'll get into. If you start looking again through some of this historical literature, even as early as 1907 in the United States, we have circulars that essentially highlight the fact that sulfur is an absolutely ideal fungicide for disease management. So this ovidium of powdery mildew of the vine, I see we have some Californians here in the audience. This is an original publication out of the University of California Cooperative Extension, and they really describe how sulfur is the best form of disease control after canopy management is implemented, though. So I would like to highlight that over 100 years ago, we were still talking about canopy management first, fungicide second, when it comes to disease control. And, we got away from that a little bit, and obviously we've come full circle. And there are some mentions in these early documents about summer phytotoxicity with sulfur. And what I really love when I start reading through some of these older documents is you really get a good context for when phytotoxicity is seen, the severity of phytotoxicity, and if there are other little tips or tricks that kind of pop out in these descriptions that might be the bigger component for phytotoxicity. So in this particular document, it essentially says, it does admit that, hey, there could be some phytotoxic effects, but only when sprayed when temperatures are at 110 degrees Fahrenheit. So that's a pretty high temperature cutoff, right? And this is, again, 1907. I also like to note for some folks that are in the audience that are extremely nervous about spraying sulfur fungicides during bloom, relative to having fruit that's entirely infected, this little gem has this beautiful comment of the favorable influence of sulfurine vines while in blossom on the setting of the fruit is even more generally recognized. And it keeps on going and describing how fantastic just doing anything other than nothing is good for disease management. So I just wanted to put that out for folks that are still in the bloom time period and maybe a little fearful of sulfur applications on vinifera during bloom. We move on to New York's similar time period. So this is a circular published in the 1910s, if you will, in upstate New York. And this is really one of the first documents that I think prompted a lot of people to get hyper-focused on sulfur as a phytotoxic potential fungicide when used in the summer. And this particular document, though, while it's often used as a reasoning or a resource that then pops up in a lot of East Coast literature on fungicide or sulfur phytotoxicity, but if you actually read this original source, you realize that they were not spraying sulfur. They were doing sulfur with lead arsenate. They applied them on hybrid grapes in the month of June. And so, yes, when you do that, they saw burn. When they use lime sulfur dust in both two native grape species, so Delaware and Concord, they saw no injury in some years and some injury in other years. And then there's a little comment of associated with high temperature and scant rainfall. But in this case, if you think of the context of New York, when you have high temperatures and scant rainfall, and you're typically growing these types of grape varieties near large lakes, you're still dealing with pretty high humidity. So it's a combination of warm temperatures and high humidity. But again, using a sulfur type product that is very clearly not something we use now because of known phytotoxicity challenges, but it is not elemental sulfur. It is sulfur mixed with something else. 20 years later, from the first California circular, we go to the second one related to sulfur use. And even here, where it describes it provides very prescriptive uses of sulfur over the course of the season, you just see additional comments related to the use of elemental sulfur on just light coating, season long. These do great things for disease management, etc. And only in a very, very tail end of this particular circular do you see a comment of a heavy coating of sulfur may cause sulfur burn when that heavy coating occurs at temperatures higher than 100 degrees Fahrenheit. So now we're starting to see a slight decrease in temperature. And again, the locations of some of these circulars and the notes, if you read deeper, are a lot of that's very region or location specific, where they will mention grapevines with excessively large canopies or those closer to irrigation ponds or natural waterways. They tend to see a lot more sulfur burn. And I think that, again, starts to add some information of is it just sulfur and high heat, or is there something else potentially causing these fears of phytotoxicity, especially since they seem to be very random and often in these notes of may cause, and the word emphasis there is may. So it's just it's a note of caution, but not something that is necessarily routine. And so really, um, but the next question is, well, how does sulfur work the way it does, and why might it cause potential phytotoxicity? So first, let's focus on what sulfur does to fungi, right? And obviously, it's a product we've been using for over 150 years, but because it works, we often just say, oh, it works. And we don't honestly know exactly how it works. We just know that it works. But I will say, if you ask an AI, they're pretty confident that they know how it works until you read the supported literature that they cite, and you realize that AI components like ChatGPT do a lot of inferencing when they are reviewing manuscripts. But fundamentally, we know, or we think we know, that sulfur works on three major modes, both as a contact fungicide, as a vapor fungicide, and something that does some intracellular conversion once absorbed by fungi to various toxic compounds like hydrogen sulfide. And so the reason why that's important in understanding phytotoxicity is a lot of those three principles, contact, vapor, and intracellular conversion, also happen with plants because it is an element very similar to many of the foliar nutrients that we might be applying to a plant. And so when we ask how might it be toxic to plants, it's again, we don't fully know, because we also don't understand how it works as a fungicide, but it's those similar mechanisms: absorbed into the plant tissue, conversion to potential hydrogen sulfide, or that conversion to hydrogen sulfide on the leaf surface, and then being taken up into the plant through open stomata. And when our stomata often open? Well, bright sunny days, but when they're not under severe water stress or when they're under high humidity. So again, we have this combination of sun, potential warmth, and high humid environments that where we see burn often show up in the literature, but it also plausibly makes sense that that's when vapors could potentially enter leaves through stomata, in addition to potential cuticular uptake of sulfur particles themselves. And then, since those kind of early days, we suddenly see a whole slew of information and recommendations that get propagated both in pest management literature, on fungicide labels, et cetera, about when to and not to use sulfur. And I think part of this challenge on the maybe vilification of sulfur is the fact of it's an exceptionally cheap and effective fungicide. And if you want people to use less of it and more of other products, you tend to kind of lean into some of those recommendations that might hold back on people's use of sulfur. But when you see temperature ranges popping up in various literature or on labels, you'll see a bunch of different ones, ranging from as low as 85 degrees Fahrenheit. We even have that in our own Pacific Northwest disease handbooks, and that's typically pulled straight from fungicide labels as to concerns about application of sulfur during high temperatures. We see temperatures also in 90s, hundreds, 104, depending on who you're pulling info from. And what my student and I especially like is when we see recommendations that say really high or really hot. What does that even mean? I don't even know. And so this is the question that we started leaning into a little bit more when thinking about this project: is why are there so many thresholds? What does this actually mean? And how can we contextualize that to bring some regionally relevant recommendations for grape growers in the Pacific Northwest, and particularly the inland Pacific Northwest? And so that leads us to what current research is, both our own and work done by others. So we'll go through a couple of those. And I'm going to talk about three major studies here: one in Australia, one in the US state of Georgia, and then the work that we did and some of the data that we've seen here in Washington state. So first and foremost, I think a really seminal set of research has been done in Australia, and is done over a number of years, about 20 some years ago. It's absolutely phenomenal data set. I just don't think it was ever formally published, because that's what happens sometimes. And you know this work was done in Australia because they spell sulfur wrong in all of their reports. And sorry, that's my dad joke for the day. So the group out of it was in this Australian state of Victoria, did a fantastic set of field and controlled environment studies using sulfur. They used a product very similar to the US product microthiol. So it's an 80% wettable granule sulfur called thiovit. And in their control, they did a series of controlled environment studies where they looked at a huge set of temperature ranges from 59 to 86 degrees Fahrenheit, several different sulfur rates. You can see these here on the screen. I have them both in grams per liter as a concentration, or the potential rate in 50 gallons per acre, or gallons of water, to kind of help you with that conversion of what you might be doing on your farm. And they noticed no matter what kind of concentration or temperature that they incubated seedlings at, they just couldn't get any burn. So there we go. So it's a highly controlled environment. But of course, things that we highly control and manipulate in the lab don't always translate to the field. And so this group went out to the field and treated grapevines, sprayed them with sulfur in between temperatures of 91 and 111 degrees Fahrenheit. They did it during the heat of the day. Relative humidity was measured between 13 and 80%. They really didn't see any. There's a whole series of studies, like 3 or 4 or 5 over a couple of years. They did not see any burn, except for one exception on Chardonnay, where less than 2% of the leaves expressed phytotoxicity. And the sprays happened when it was 104 degrees out, and only the young leaves had expressed phytotoxicity. So that's an extremely low rate of potential burn. And so their take home is, hey, there's not going to be burn if you use sulfur at high temps unless relative humidity is more than 70%. And that's what happened at this particular time period. I think they treated a little bit earlier in the day when humidity was high, and then temperatures raised up. Again, they tried to target spraying during the heat, but that didn't always happen. The one consideration that they noted in their particular trial, which we'll also talk about at the end of the session, is spraying when vines are water stressed, and what that might do of comparing ambient temperature to leaf surface temperature during really high heat events, and how that might increase vapor activity of sulfur. The next study that we'll talk about is more recent. So it was in the US state of Georgia. And this particular study was actually done at the same time as the study that I will be describing here. So that it wasn't a coordinated effort, but were two programs that did heavily talk about this particular type of evaluation. And so, yes, they do grow Vitis vinifera in US Georgia. It's not just peaches. And so what they did was they went out, it was a 2-year summer study, and they essentially had single vine replicates, which is fine. And they sprayed 2 times at an individual site. So they had a couple different, it's a smaller study, but pretty good field data. What's really interesting with these guys is they hyper focused on spraying during the peak of the day. So they actually went out and sprayed during the heat, not necessarily the morning when forecast temperatures would go. And so they sprayed between 21 and 33 degrees Celsius, and between 40 and 80% relative humidity. So again, pretty moderate temperatures. 33 is quite warm for the East Coast. They used a very high rate of sulfur, so almost 10 pounds in 50 gallons. So that's kind of the max label rate at a pretty concentrated application. And while they did see higher incidences, so that's just the frequency at which burns showed up, about 46%, so that's much higher than Australia, the severity of all that burn was very, very low, so less than 1%. So we're talking just a little spot here and there, maybe a slight margin burn on a leaf here and there. And their big conclusion was, we had a hard time getting burn in vinifera, and this is essentially would not pass the CAR diagnosis test. So if you were driving by the vineyard, you would not have seen this type of sulfur burn. You really had to get in there and inspect to be able to pick it up and notice. They evaluated microthiol disperse, so that was the formulated sulfur product that they used in their trials. So that brings us to what we did here in Washington State. So again, our trial was at the same time as the group out of Georgia. We had very similar questions. We wanted to see, we talk about sulfur, and obviously Eastern Washington gets very hot. So we have a lot of people that stop sulfur kind of mid-season. But sulfur is a great fungicide for use of either tank mixing or standalone for fungicide resistance mitigation. And it's just a good powdery mildew fungicide in general. So, and also we are going into a period of idling vineyard times, or times where we have to watch, we're always watching budgets, but time when budgets are watched a little more closely. And sulfur is a very inexpensive product. So are we handicapping ourselves from the use of sulfur because we have these fears of potential burn on grapevines? And so that's what my graduate student Jesse decided to look at. So first, we wanted to evaluate things like environmental conditions. So we did a series of outdoor experiments and controlled environment experiments. In our outdoor studies, we have 3 years of data from that where we used an established vineyard. We also used potted vines, and we targeted treatments while we treated in the morning, because that's when you should be spraying, not in the middle of the day when drift, et cetera, is quite high. But we treated in the morning, and we tried to target days where the temperature would be above 32 degrees Celsius. And so I'm going to get that in there for you. And so that's about 90 degrees Fahrenheit. So that was our target. We tried to get those days. And we did a couple days that were below that just as a control. In our controlled environment study, we had a very set regimen of kind of moderate and high temperature coupled with moderate and high humidity. So essentially 4 environmental combinations. And we used detached leaves in that particular assay and actually evaluated young leaves and old leaves to try to get see if there is a leaf age effect. We did look at several different concentrations of sulfur and 2 sulfur formulations. So we used, they're both micronized sulfur. So we used Wilbur Ellis dry flowable, and we also used microthiol. So same rates. We just wanted to look at 2 different, similar sulfur types, but with slightly different formulations to see if there was a difference. I will say in our preliminary studies, we looked at the American unit equivalent of 3 pounds in 50 gallons, 4 pounds in 50 gallons, and 8 pounds. And in some of our early stuff, we got very little burn, even at 8 pounds. So for the rest of the season, we stuck at kind of like that 8-pound, because that's about, honestly, max solubility. The 9.8 pounds is a very thick sulfur spray, if anybody's ever tried that. So we did not look at low rates of sulfur. We looked at that upper end of what's allowed on the label. And what we did in addition to help beef up our study relative to the ones in Australia and Georgia is we also tank mixed some of these sulfur products with different adjuvants. So while we had a sulfur only control, we also mixed sulfur with adjuvants, including non-ionic surfactant spreaders such as Embrace, Complex, New Film P, and Silhouette. You can see those volume by volume percentages there, the screen. Yes, we actually tank mixed sulfur with stylet oil at one point too, but if you notice here, we used a rate that makes of stylet oil that's more of a surfactant level than actual fungicidal. And then we also mixed it with non-ionic penetrants, such as a product like OroBoost. So we were trying to look at when we add certain additives to the tank with our particular sulfur treatments, is that increasing potential phytotoxicity? Because oftentimes spreader stickers or penetrants help pull products into the leaf surface. And if cuticular uptake is one of the mechanisms by which sulfur can be absorbed to cause burn, perhaps these products might increase that risk. Then lending to the idea is sulfur really the problem? Well, yes, it's the one causing the burn, but is sulfur with something else actually resulting in the expression of phytotoxicity? Just an example of what those different treatments looked like. So again, kind of outside established vineyards, pot lots with 1-year-old cuttings, and then a detached leaf assays. And in the detached leaf assays, these leaves were grown in greenhouses, and then we used a growth chamber that was programmed at the predetermined environmental conditions. For those that are interested, these are some of the field conditions on the days that we sprayed. Maximum temperatures and maximum relative humidity within 4 hours and 12 hours post-spray. So you can see immediately after sprays, temperatures were pretty moderate, but we actually hit pretty high temperatures on some days, including up to 39.9 degrees Celsius. So very, very warm. Got my little conversions there for you. So we were hitting close to 104 degrees Fahrenheit. So spraying in the morning on a day that would reach that high. As you probably noticed too, maximum humidity achieved is usually in the morning, and because relative humidity is relative to air temperature. So typically as air temperature goes up, humidity drops. And here in Eastern Washington, while we do have some relatively high humidities, like that 70% threshold that was found in Australia, that really didn't happen until we start hitting dew point in the fall. So typically during our general spray windows, usually July and August, May, we typically are at humidities, even within 4 hours of the morning of a spray, well below that 70% threshold. And again, it's a couple overview, just as a reminder, unlike the Georgia study and some of the Australian studies, we did not spray during the peak of the day in the evening. We sprayed in the morning. for reasons of one, that's when you are supposed to spray due to potential inversion and drift risk. Two, due to heat laws in Washington state. In theory, if you don't have an air conditioned tractor, you shouldn't have people in Tyvek suits spraying when it's above 85 degrees Fahrenheit. And three, we really wanted to focus on what was the most common types of sprays. And we do know many people here in Eastern Washington actually spray overnight, so when temperatures are much cooler. All of our sprays were applied using a backpack sprayer, calibrated to deliver 50-gallon per acre equivalent. And this was a motorized backpack sprayer, so it had consistent pressure and delivery output. So it wasn't a hand pump. We had a consistent PSI. And we used commercial nozzles on the sprayer, not necessarily the little brass ones that backpack sprayers often come with. And again, applied at that 50-gallon per acre equivalent spray coverage. All right, so our field studies. So what did we find? Well, the spoiler alert here is we found very little. So my poor student did a bunch of, I mean, he did a fantastic job, and he sprayed and sprayed and sprayed and sweated and sweated and sweated in Tyvek suits. But it really didn't seem to matter. We no matter what time of day, heat or no heat, we had a really hard time getting phytotoxicity out of any of our treatments. And you can see that here. So while you do see some bars that have high spikes, I would like you to look at the X or the Y axis here and notice that we maxed out at 10% potential severity on phytotoxicity when with a particular sulfur and adjuvant combination when we sprayed on days that reached above that 32.2 degrees Celsius threshold. And as a quick reminder, 32.2 is about 89 degrees Fahrenheit. And so these obviously went days from 89 up to 104. So really, typically what we found is severity ranged from 0 to maxing out at about 6%, plus or minus some there as you see. And then when we compare, and so these are the different sulfur, so the microthiol with complex, microthiol with embrace, stylet oil, etc. And when we also then compare the difference between that particular adjuvant or sulfur and adjuvant combination sprayed on a hot day versus a cool day, we notice in most cases it didn't matter, but it did for products like Embrace, New Film P, and a little bit on our own sulfur control. So here it does show that there is a slight increase of potential phytotoxicity when sprayed on hot versus cold days. But I would like to emphasize what this number is, which is less than 1%, so 0.6. But there was a pretty significant increase when we mixed sulfur with Embrace. So that's one particular adjuvant that we struggled a little bit with sulfur burn. But again, overall phytotoxicity was very low. And then when we sprayed on days that were less than 32, we didn't see any burn, with the exception of water. And on our water, we did get a little bit of water burn when we sprayed on certain cool days. When we look, so that was with microthiol. When we look at Wilbur Ellis dry flowable, very similar results. We didn't use as many adjuvant combinations with Wilbur, just simply, there's time and space factors that we have to fit these trials in. And again, I would like to point out the y-axis here. Overall field severity was exceptionally low. The one particular combination that we saw higher phytotoxicity in when we treated on warm days versus cool was once again Embrace. This is again a potential surfactant and sulfur combination that didn't work so well. And we did see a little bit higher sulfur burn with Wilbur Ellis dry flowable compared to microthiol, but pretty minimal again, and very low phytotoxicity overall. But again, the main point is overall very low phytotoxicity with a potential surfactant or adjuvant effect when applied on a hot day. And that particular one was Embrace. We saw a little bit higher burn with that. When we looked at our potted vine studies, so again, these are 1-year-old cuttings, similar effects. Again, you're like, oh my gosh, Michelle, I see all these bars. These are much bigger, more burn than what we saw in the previous field studies, but it's not. Again, look at the y-axis. The maximum severity we saw when you factor in error was 5%. So again, very, very low phytotoxicity. And to kind of place the context, these were vines that were grown in pots on a gravel lot in the full Eastern Washington sun, sprayed in the morning on hot days. So again, overall phytotoxicity exceptionally low. And again, only one instance where spraying sulfur plus a surfactant on a hot day had more risk of burn than when we sprayed it on a cool day. And that was once again when it was combined with the surfactant Embrace. but again, very, very low phytotoxicity overall. We did that exact same study with the Wilbur Ellis dry flowable, and again, very low phytotoxicity, a little bit higher when we tank mixed with stylet oil, as one would probably expect. But one thing we did notice with this particular formulation of sulfur, there was, anytime we treated on a hot day versus a cool day, we did have more burn on warmer days than we did on cooler days. And so that might lend that different sulfur formulations might result in a different potential risk of phytotoxicity. It doesn't mean they're any better or worse from a fungicide effect, but oftentimes, depending on how products are manufactured, if they have a wider range of particle size in the manufacturing process, so a little bit less consistent, you can end up with really big particles of sulfur in that potential mix. Those usually tend to be less phytotoxic because they're harder for the plant to take up, to very, very fine particles. So certain formulations or certain generic products that may have a more inconsistent manufacturing process may increase or decrease risk relative to the actual particle size that is in that formulation. So just something to keep in mind. But again, the overall take home was very, very low phytotoxicity in the field when spraying these products in adjuvant combinations at high temperatures versus cool temperatures. But there was the potential increase in phytotoxicity risk when an adjuvant was included. When we look at our controlled environment studies, we only looked at microthiol in this particular case, and again, programmed various combinations of higher temperature, higher relative humidity, high temperature, moderate relative humidity, moderate temperature, high relative humidity, and moderate temperature, moderate relative humidity. And you can probably just see across the top here visually that when you have high temperature, high relative humidity, the risk of phytotoxicity is pretty high relative to moderate temperature, moderate relative humidity. And so what the take home message here is that yes, heat is a driver for potential phytotoxicity, but whether or not you achieve that maximum phytotoxicity is driven by the relative humidity at the time of application. So higher temperatures coupled and then followed with higher humidity is absolutely necessary in order to achieve extremely large boosts, if you will, or bumps in phytotoxicity. For those that are paying close attention, you might notice that these phytotoxicity numbers and the x-axis is much higher. So we go up all the way up to kind of upper 40s in terms of percent severity. We had 100% incidence in these cases, but the severity was that kind of in that 50% mark. Again, would like to notice that a couple of the key differences between field and controlled environment studies is one, in field, we experience diurnal swings in temperature and humidity. In a controlled environment, it is a controlled programmatic set temperature and humidity for a continuous time. So it's these environmental extremes or moderations, if you will, for an extended period of time. In addition, the leaves are detached while we do grow them in a Petri type assay to help keep the leaves alive. In high temperature situations, water can evaporate quickly, so that increases the potential phytotoxicity of ratings. And it's not really phytotoxicity, it's just desiccation, but it's hard to distinguish those. And two, these are leaves that are grown, or three, probably the bigger component is these are leaves that are grown in a greenhouse, and greenhouse grown plant tissue tends to have a less robust cuticle compared to tissue that is developed outdoors. So general risks for things like phytotoxicity or desiccation are quite high regardless of what you're spraying on it. It's just the leaves are pretty weak. But again, the trends hold in that we really need high humidity in order to achieve maximum phytotoxicity. So when we think about that in terms of environmental context, that ability, and at least in Eastern Washington, to have high temperatures at the same time of very high relative humidity don't really overlap, right? So this is the zone of high temperatures. So this is weather from Prosser in 2025. Obviously, absolutely, we start to hit temperatures between 32 and 37 degrees, or kind of those fear thresholds of sulfur a lot. Hence why we could do our study and in field experiments. But very, very rarely, the blue line here is relative humidity. Do we hit relative humidity, average daily relative humidity that gets even close to 70%, except for maybe in April and early May, which again is not really a time we're doing a whole lot of sulfur treatments, and is definitely not a time where we often have heat spikes. There are exceptions to that, and we'll talk about that in a little bit. But that the ability or the likelihood of us having a high temperature, high humidity combination in the field during a time when we're routinely doing these sprays is pretty low. Unlike the state of Georgia, when they were spraying during their high temperature events in the middle of the afternoon, and they could very much have 80% relative humidity during those temperature peaks. So what is the big take home from all of this work? And I showed obviously just 3 slides with some data sets on there that were combinations of, 3 years of hard work by a student and a lot of backpack spraying. But we did all that work ultimately to show that phytotoxicity from simple sulfur sprays is the risk in the field is very low. And of course, I was hoping at the end of this project to have all sorts of fantastic burn photos for you guys to show what sulfur phytotoxicity looks like, et cetera. But we had to work very, very, very hard to get that very little bit of burn that we did see in some of our ratings. What we did notice, though, is that adjuvants or other things that could be mixed into the tank, and we'll talk a little bit about that next, can increase that risk of phytotoxicity. So yes, sulfur is what's causing potential burn, but by itself, the risk is very low. But you start mixing things in, you could potentially increase that risk. And our controlled environment studies really showed that while maximum risk is driven by high temperatures, in order to really maximize that risk, you have to have high humidity as well. So there is a very specific combination of environmental conditions and potential tank mix partners that increase the risk of phytotoxicity. So how do we place that into context? What can we do, use that? How do we use that information moving forward? What to look out for? And what's a potential myth in terms of sprays? So first, let's talk about best spray practices. So in Australia and Georgia, they often did treatments in the afternoon. Here in Washington, we chose to treat in the morning because that's when most sprays should happen. But in theory, when you are doing your fungicide treatments or any sprays in the vineyard, you should avoid spraying when there's a temperature inversion, when winds are high, and when temperatures are above 85 or below 32. And that latter one really doesn't necessarily have anything to do with the actual fungicide itself or like phytotoxicity, but it has everything to do with what that might do in terms of evaporation of your spray, pathogen or pest activity, and the volatility of potential tank mix partners at certain temperatures, whether those, particularly volatility at the lower end. So products sprayed when things are freezing are not necessarily good either. So there are key windows on when you should be spraying in general, and often those do not align with high temperatures. And again, not from a phytotoxicity risk, but because of just will that product evaporate before it even meets the canopy. So it's a drift risk. And also, of course, in the P&W, we have a number of worker safety rules on just general human health and protection of doing certain types of treatments during heat events to help prevent heat-related injuries and illnesses. Also, what are you spraying? So when you tank mix, when you're with other fungicides, it's very similar to tank mixing with an adjuvant because you don't necessarily, with an adjuvant, you know exactly what you're putting in the tank, or at least you hope you know. Oftentimes with adjuvants, we don't fully know how they work. But certain modern formulations of fungicides have already been formulated to improve their own adherence or rain steadfastness or absorption. So do you know the formulation of the other products that you're using, or are those other products already formulated to improve cuticular uptake? And essentially, by tank mixing them with sulfur, you're increasing your potential risk for that sulfur to follow that same pathway using that kind of already built-in adjuvant or surfactant that might be in that other chemistry formulation. So essentially, the more we add to the tank, the more potential risk we have with actual application incompatibility. So this is not cause, bubbling over, condensing in the actual spray tank, but could increase phytotoxicity on the plant because you're essentially having a nice hot cocktail of things that you don't necessarily know how they all interact. Also, how your water quality might be interacting with all those products combined. With nutrients, same thing. As I know we do a lot of foliar micronutrient and macronutrient sprays here in at least in the P&W. But oftentimes to improve that cuticular uptake, you have to add specific adjuvants to improve that that product intake. And usually when I do get a report or a call or of an image from somebody about sulfur phytotoxicity in the field, by the time I look at the spray record, there's about 8 things in that tank, including often micronutrients and 2 or 3 adjuvants to improve the uptake of those micronutrients. And so, yes, sulfur might be the cause there, but we shouldn't necessarily blame that versus everything else where we're throwing into the tank that's actually exacerbating that risk. And then finally, as a note, again, that sulfur quality is not all products are the same. They might be micronized sulfur type products or fall into that category, but there are technical grade or variation that's allowed. And so one formulation of sulfur might behave slightly differently than another. So it might carry a higher risk or a lower risk of phytotoxicity, depending on the size of the particles or the consistency of size and particles in that mix. So if you are using a particular sulfur product that was not mentioned here, so something that wasn't microthiol or Wilbrellus trifluorable, so maybe Drexel or Coidyl, you may have to do your own on-farm testing to see if they might carry a lower or higher risk just based on their formulation consistency. And so where are you spraying to might influence that. And I think the where really kind of falls into that influence on microclimate. The what influences kind of the interactions with the potential plant cuticle, and the where is environment. So irrigation influences. So active irrigation, if you are actively irrigating at the time of a spray, so this is again for inland irrigated vineyards, you are increasing vineyard humidity and potential surface moisture. So we have seen risks where if somebody's irrigating during a spray, that humidity in that vineyard slows down the drying time of the sulfur solution on the leaf, and that can increase potential uptake and phytotoxicity. But on the converse, if you're deficit irrigating later in the growing season, water stress can increase leaf surface temperature. And since temperature is a driving factor for phytotoxicity, you could increase the potential risk of phytotoxicity. So that's the big difference is, are we deficit irrigating, extreme deficit irrigating late season where the plants are very water stressed and therefore leaf surface temperatures greatly exceed air temperature? That could be a potential problem if you have a lot of residue on the leaf. Hence what we saw in that 1929 circular from California, or if you're actively irrigating during the event, so increasing humidity. The other thing too is just look around your vineyard. So if you are a location that has a lot of actively transpiring ground cover, you have proximities to ponds or irrigation canals, you are in a situation where you might have relative microclimate, relative humidity that's much higher than the surrounding area. So your temperatures may be just as hot as your neighbors, but your humidity might be higher as well. So you may experience certain parts or certain blocks in your vineyard that have an increased risk for potential sulfur related burn, because it's just an area that holds more moisture. And of course, the converse from humidity is increased heat. So often in the other end, if you have totally bare soils, southern slopes, or a lower plant density, so higher kind of reflective light versus canopy, you could potentially increase the heat in your vineyard. And of course, we do that for various other reasons. But if you have sites that are totally exposed, very hot, very dry, you could obviously increase the potential risk of sulfur burn relative to other blocks or neighbors. So if you are experiencing burn or what you perceive as burn, and a neighbor does not, perhaps look at those other vineyard factors as well. So some closing thoughts and some shameless plugs here for WSU. For those who are not aware, WSU has transitioned our pest management guide to a digital version. So we no longer print a nice little PDF or circulate an electronic PDF or print a booklet. So if you'd like to check that out, here's a QR code for that. It's also available on the wine.wsu.edu website. And so as we add more information on fungicide risks, et cetera, so you'll start to see our information in this guide, especially related to like sulfur and heat. You'll see some notes and comments being adjusted there as well. We also recently, as a part of upgrading kind of our digital pest management, WSU's V&E website has also gone through a major upgrade. So we have a nice, easy to navigate portal for various grape growing and winemaking extension-based topics. So you can access that here as well. If you don't have time to scan a QR code or look up a URL, again, just remember it's wine.wsu.edu, and you'll be able to navigate accordingly from there. So there's a whole series of navigation bars from our pest management guides and extension information there as well. Of course, none of this is possible without funding and people's help. And so I do want to thank the Washington State Wine Commission and through the Washington State Grape and Wine Research Program, WSU, and the Auction of Washington Wines for funding for this particular project, and also the Northwest Center for Small Fruits Research. So two larger organizations that help fund the work, and particularly fund the graduate students and people that help do all this work. And again, I know we always talk with students, when you summarize data into 3 slides, it's like we want to use 16 or 17 to kind of express how much work went into these types of things. But those 3 slides took 3 years of work and a lot of sprays and a lot of leaves and a lot of scouting and assays to generate. And again, all that work was done here by a master's student, Jesse Stevens, who graduated this spring, and by my technician, Maria Morales, who kind of keeps everything going. And then we had a lot of support from our summer undergrad last year, Jason Ritter, who recently graduated from Rutgers University. So they did a lot of work in this process for evaluating, spraying, growing grapevines, spraying them again, mixing fungicides, etc. And of course, Jesse wanted to make sure I include a special thanks to all the young Chardonnay vines that we sacrificed in stripping leaves off for this particular assay. So with that, Julie, I think we can take some questions. I'll just leave your screenshot up if folks would like to look for that.
Sounds great, Michelle. Thank you so much. Let me go to the chat. And if folks had any questions, I am not seeing anything in the chat. My gosh, you are so thorough.
No, there's Q&A. So we have a Q&A tab, and I see a couple from folks here. So I'm going to read them real quick.
Oh, it's under more. Yeah, my bad. It's under more.
Yep. So Achala asked, Chala, all this was done on Vitis vinifera Chardonnay. We did do some small assays. Part of this original study was to also look at some genetic components. So we had some hybrids, and we also were going to look at Concord. We did a couple preliminary trials with those, but we ran out of time and space to continue on with that. But again, all this trial was done on own-rooted Vitis vinifera Chardonnay. And then the second question, were they sprayed just once with sulfur? And so in our evaluation trials, so they actually weren't, unless they expressed phytotoxicity, right? So we had some treatments looked at 24, 48, 72 hours post for rating purposes. But then oftentimes we would treat those same vines 2 or 3 weeks later on a day that, we obviously had to screen for temperature. So we didn't look at the cumulative effects of sulfur in that particular case, which would be something that would be very interesting to look at, particularly environments that don't have increasing rain events. But the intent there too is not everybody except those outside of an idling program would potentially be using sulfur. I know there's some tank mixes folks out there that like to use sulfur with everything, but most folks are not necessarily using sulfur with every single spray, simply because of certification programs that have a limit on the total amount of sulfur that's used over the course of the growing season. But absolutely, I think that cumulative effect would be very interesting to follow through on the study. And we did do treatments up to veraison, but I know up here in Eastern Washington, we don't typically treat sulfur for powdery mildew management up to veraison. We usually stop our treatments much earlier. And so then Madeline asked, what about burn on fruit versus phyto or versus foliar? We saw absolutely no burn on fruit in all years of the study, so we didn't present on it. But no, we saw absolutely no burn on fruit. So the reason why we didn't show that data is because it was 0 and a very boring 0. So Joey asked if the old circulars differentiated between sulfur dust and wettable sulfur formulations. So a lot of the that's very hard to tell, but if you look historically through fungicide uses, most older fungicide use of sulfur in vineyards was dusting sulfur. Kind of the good wettable formulations didn't really pop up until a little bit later. So the focus on a lot of those older circulars were dusting, but in many cases, some people did mix them with liquid if they wanted to spray in a different way or they needed different types of coverage. But majority of it was based on dusting sulfur. And then Benjamin asked, can humidity eclipse heat in terms of danger for phytotoxicity? So you do need heat. So humidity is secondary. So if you were at say 25 degrees Celsius, so 28, so 82 degrees, and you had really, really high humidity, this risk is still probably pretty low. But when you start to add a little more heat to that, then humidity does become a bigger factor. So I know your concern is like, what happens then, if you spray at night and then suddenly, obviously at night humidity bumps, but again, you do need that heat plus humidity. So it's heat first and humidity is an additive effect. I will say the only times we could see burn, both here and then I do a bunch of fungicide trials for other things when it does pop up, again, obviously very low, is usually not in this midsummer. A lot of those events that caused burn happened in May treatments when relative humidity and dew point were higher in the morning, but we had those random high sun heat spikes that we occasionally get in May. That's the days that we would typically see sulfur burn, which is a bit ironic because we don't worry about sulfur burn during May when we almost always use sulfur, but we're more concerned about it later summer when we don't really have that humidity and temperature combination. Um, so Kyla asked about Merlot. Well, we didn't evaluate Merlot, so I can't talk about variety specific differences in sulfur burn. So I'm unable to answer that. And so then Pierre asked, would you expect burn to be similar if using dusting? So Pierre, I expect burn to be a lot less when using dusting sulfur because you're not introducing that additional humidity into the system or surface water in the system, and that duration of how long that surface water takes to dry. It's that wetness that can actually increase potential cuticular uptake when that droplet is on the leaf. So I would actually expect burn to be much, much less with dusting sulfur versus a liquid applied sulfur.
I
And
think
so
we have one from
Patty,
Patty.
yeah. Would you expect burn on both fruit and leaves if there is phytotoxicity early in development? Ooh, so yeah, that's a great question, Patty. Um, yeah, so I would expect that, right? But that's one thing is we just didn't see it because we just had so little phytotoxicity. So, I think if we were dealing in a situation where phytotoxicity was potentially higher expressed, like if you were to truly get burn, perhaps obviously on all tissue, you might see that potential burn. But it could also be a difference between how much, how active stomata are on in and around on foliage versus what other points of entry on a developing grape berry there might be for those sulfur vapors to enter into the berry. But again, fundamentally for us, it was just so hard to get burn, period. And I think that's why we don't see a lot of fruit data even coming out of the Georgia studies or Australia's. It's really hard to elicit burn, period. And so you just don't see it on the berries.
Do we have any others? Last call for questions for Michelle. Seeing none show up, let me close the Q&A. Michelle, thank you so much for your time and for sharing the data today. Thank you to everyone who tuned in. Again, I will have this recording posted on the Washington State Wine Commission website. Just go to the WAVE section of that website and it'll be in the list. So thanks again, folks, and we shall see you on another edition.
Thank you, Julie.